The James Webb Space Telescope has quickly become humanity's most powerful window into the cosmos. Its mission goes far beyond capturing beautiful images. It is designed to investigate the origins of stars, galaxies, and even the hidden chemistry of distant planets. By doing so, it helps us better understand not only the universe, but our own place within it. Recently, astronomers pointed Webb toward a star system about 120 light-years from Earth. What they discovered has surprised the scientific community. Signs of carbon-based molecules were detected in the atmosphere of an exoplanet known as K218b, a world unlike anything found in our solar system. This planet, about 8.6 times the mass of Earth, may belong to a rare class of Hycean worlds, planets with hydrogen-rich atmospheres and the possibility of deep oceans beneath them. Such conditions make K218b an intriguing candidate for habitability. The molecules identified, including methane and carbon dioxide, are often linked to geological or even biological processes on Earth. Their detection has sparked global discussion about whether this planet could support life. Earlier hints came from the Hubble Space Telescope, which first revealed traces of atmospheric gases around K218b. Webb, however, with its advanced instruments, has now provided far more precise data. Located in the constellation Leo, the planet orbits a relatively cool red dwarf star and sits within its habitable zone, the region where liquid water might exist. Adding to the excitement, some researchers have reported possible evidence of dimethyl sulfide, DMS, a compound on Earth produced almost exclusively by marine life. While the detection remains uncertain and needs confirmation, its presence would be a game-changing clue in the search for life. The details come from a technique called transit spectroscopy, where scientists analyze starlight that filters through a planet's atmosphere as it passes in front of its star. Each molecule leaves a unique signature in the spectrum, allowing astronomers to reconstruct the chemical makeup of distant worlds. Webb's unmatched sensitivity, thanks to instruments like NIR-SPEC and MIRI, has delivered the clearest spectral fingerprint of a sub-Neptune planet within a habitable zone to date. Yet, K218b may not be a simple ocean planet. Its size, 2.6 times Earth's radius, suggests it could also have high-pressure icy layers beneath its atmosphere. Whether its oceans are stable, warm, and chemically balanced enough for life remains an open question. Further observations with Webb and other telescopes will be critical in answering this. But Webb's discoveries don't stop at exoplanets. In a separate study, scientists used it to identify complex carbon molecules, polycyclic aromatic hydrocarbons, or PAHs, in a galaxy that existed more than 12 billion years ago. These molecules are similar to those found in petroleum or smog on Earth. Their detection at such an early point in cosmic history suggests that the chemical building blocks of life formed much sooner than we once believed. What's even more astonishing is that this galaxy, already as massive as the Milky Way, had enriched itself with elements like carbon and oxygen far earlier than expected. Webb not only detected these molecules but also mapped their distribution, revealing patterns that challenge current theories of galactic evolution. Each of these discoveries, oceans on distant worlds, organic molecules in ancient galaxies, brings us closer to answering humanity's oldest questions. Are we alone? How common are the ingredients for life? And how early did they emerge in the universe? With the James Webb Space Telescope, humanity is witnessing the cosmos in a way that no generation before us could have imagined. Every image, every spectrum, every faint trace of light it captures is like turning another page in the story of creation itself. Webb doesn't just show us distant stars, it reveals how galaxies form, how planets breathe, and how the chemistry of life may not be unique to Earth. We are now peeling back layers of cosmic history. What once seemed unreachable, the first stars, the earliest galaxies, the atmospheres of faraway planets, has come into view with stunning clarity. And with each new discovery, the universe appears not as a static backdrop, but as a living, evolving stage. A place where complexity emerges naturally, where order rises from chaos, and where the ingredients of life may be scattered far and wide. For decades, the question of whether we are alone lingered as a philosophical debate. Today, it is a scientific pursuit. When Webb detects methane, carbon dioxide, or other carbon-based molecules on a distant exoplanet, it does more than measure chemistry. It whispers the possibility that somewhere out there, conditions might be right for biology to take hold. The dream of finding life beyond Earth is no longer confined to science fiction. It is being tested, observed, and studied in real time. And what makes this era extraordinary is not just what Webb can see, but how we can interpret it. Artificial intelligence now works alongside astronomers, uncovering faint signals, subtle patterns, and complex fingerprints of molecules hidden in the data. This partnership between human curiosity and machine precision means we can push deeper into the unknown than ever before. The universe, once silent and mysterious, is now beginning to reveal its voice. But each answer sparks new questions. If oceans exist on worlds like K218b, are they calm or violent? Do they host simple chemistry, or something more? If complex carbon molecules are already found in galaxies formed just a billion years after the Big Bang, how early could life have taken root in the universe? And if life is common, what might intelligence look like under alien skies? Would it be biological like us, or something entirely different, born of physics, chemistry, or even energy itself? These are not idle questions. They redefine what it means to be human. For the first time, we can imagine a future where the universe is not empty, but alive. Where the story of life is not singular, but cosmic. Where we are not an exception, but part of a grander pattern written into the fabric of space and time. The search for life is no longer a distant dream. It is unfolding right now, one observation, one spectrum, one discovery at a time. Each piece of data is a clue. Each planet is a possibility. Each signal is an invitation to look closer. And while Webb is still in the early years of its mission, what it has already revealed suggests that the journey ahead will be even more profound. The coming decades may not just teach us where we came from, but whether others, too, are out there, wondering, searching, and reaching across the stars. So, as we stand at this turning point, the challenge is clear. We must keep listening. We must keep searching. And we must be ready for the answers, no matter how extraordinary they may be. Because the universe is speaking. And for the first time, we are finally learning how to understand its language.